what's under the hood in this robot arm. I'm just going to show you a few things that are on the inside of this robot arm. There will be a full list in the description of this video of items that I've put on the inside, but most of this is 3D printed. Alright, so this portion of the forearm right here was the thing that gave me the most trouble. When I slotted it into this portion of the wrist up here, it just didn't fit, and it just felt wrong. But it wasn't until a couple of days later when I printed off the back portions that when I bolted this down with a 3mm bolt and a nut that is super glued to the inside, that it gave enough forward pressure to allow this to click into place. And we can hear that there's just enough bounce there to click it in. And there we go. So I like some people who have assembled this and the designer has super glued these two pieces together or epoxied them together. I'm going to leave them apart because I feel like this is enough pressure so that while I'm still working on it, I can get in and out of the arm reasonably easy. Alright. Now, I've had to cut the support. This is an anti-warping support for while you're 3D printing. The designer said to cut the whole thing out, but I just cut a little bit out because I think it kind of helps. Because that little portion just rests right here on the top of this tensioner. So I'm going to take the back piece off now. Alright, and we can see that there's another anti-warp support on this. So it actually provides a lot of stability. And if I just squeeze this a little bit, you can see that there's just a little bit of tension on there. Alright, so these are my 5 servo motors. Each one controls one wrist. They are pulse modulation with control servo motors. So there is a minimum threshold for that width, and then there is a maximum. And when you control this with the Raspberry Pi, when you set it up, I've set it up so that if I have a pulse width modulation wave of under 5, that means nothing as I'm saying it right now, but when we go and explore the code in another video, that 5 will make sense. So my lower limit is 5 and my upper limit is about 28. So what I've done here is for a fully opened finger, I've set the pulse modulation control to 11 and fully closed to 24 at max. Now, because all of these are a bit different, some servo motors are calibrated a little bit differently. So in the code video that I show you, you'll see a little discrepancy that I range from 9 to 24. And sometimes the max is 20. But that's alright, because as long as each servo motor is calibrated individually, we're fine. So I'm using braided fishing line as my tendons, and it's working reasonably well. Now, sometimes there's a lot of tension on here, and I think it's starting to cut into the tips of the fingers a little bit. If I show you that, if I get a good, it's really hard to see with my camera, but when I got in there with a magnifying glass, it looked like some of it was already starting to bite into the finger joints. Not a big worry. I just reprint some of those if they get destroyed and then reattach them. But I want to talk about this right here. This is a tensioner, and there's springs down here to keep tension on it. And you can see some of them are loose and some of them are tight right now, and that's just because I don't have any power supplied to the servo motors. But the main reason for these springs and this little bit of tube, the tube is to keep the springs from wearing down the string, and the spring is so that when the wrist rotates, it has a little bit of pull to let the tendon stretch a little bit so that the wrist can rotate without pulling the fingers closed. Because if we had constant tension and we rotated the wrist would do this, and it would close. So by allowing the spring in there, we can turn the wrist and keep the fingers open. I'll demonstrate that in another video. I still don't have the wrist moving. I have done a test on it, but I wasn't quite satisfied with it. So that'll be in another video. All right, thank you.